a times b to the power of x plus q are called exponential functions. Okay? So, okay, if you see a function, of the form y equal to a times b to the power of x plus q, we call that function an exponential function. Okay? Now, it's very important for you to distinguish the four functions. Okay? That is the linear. The linear, let me just use a different color. The linear is of the form y equal to mx plus c. Okay? You did that in grade 9. And I also repeated it in this grade because it's very important for you to know the linear function going forward. It's a very, very important function. Okay? Up to metric, not only under functions, but even other topics. Later, you do what is called analytical geometry. You also do the straight line. Okay? Then we had the quadratic function, which was the form y equal to ax squared plus bx plus c. Why are you bringing all that? So we have your linear quadratic, then the hyperbola, that's y equal to a over x plus q. Okay? Then the fourth one is the exponential function. The exponential function is a function of the form y equal to a times b to the power of x plus q. It's called an exponential function because the x is an exponent. The x is an exponent. Okay? The x is an exponent. The hyperbola has x as a denominator. The quadratic function is an exponent of x which is equal to 2. The straight line is an exponent of x which is equal to 1. So you must be able to differentiate between the four functions. Yes?
So how come the quadratic function is the same base as what we did? Because we learned it in the form ax squared plus q.
Oh, okay, I gave you a grade 11 one. Okay, no, it's plus q. Okay, the one which I wrote is a grade 11 one. Okay, please if you wrote it ax squared plus bx plus c, please change that. It's ax squared plus q. Okay, it's ax squared. The one which I wrote is a grade 11 one. Anyway, for this grade, the quadratic y equal ax squared plus q. Right now, it's very important for you to distinguish between the four functions. Okay, up to now we have done these three. Okay, now we are doing the last one. Now the last one requires knowledge of exponents. Okay, you can see in the name that it has got the word exponent in it. Okay, so your knowledge of exponents that you did in term 1 is required when you're doing the exponential function. Now, the two constants, that is the a and the q, they have got an effect on the graph. A and q have got an effect on the graph. Okay, now the q represents vertical shift. We know that. Okay, so this q and that q, they all represent the horizontal, the vertical shift. Okay, remember I told that in grade 10 there is no horizontal shift, it's only vertical shift. Okay, in this grade there is no horizontal shift, it's only vertical shift. So the q represents a vertical shift. If q is greater than 0, the graph goes up. If the q is less than 0, the graph goes down. Okay, and I've told you about that before. That's not a new concept. So by now, if you've been going over your stuff, you should be aware that the q represents the vertical shift. If it's positive, the graph goes up. If it's negative, the graph goes down. Okay? Then the A now, okay? The A, okay, before I move on to the A, that Q also is the value along the horizontal asymptote. An exponential function, there is one asymptote. Okay, I'm just letting you know, but later we're going to talk about the properties. But the exponential function has got an asymptote, which is a horizontal asymptote. It only has one. Okay? Now, the effect of A. This A here, it has got an effect because generally, an exponential function, if I were to sketch it, okay, please, this is a sketch, it will look like this. Okay? If A is positive, okay, the graph will curve upwards, like this. If it's negative, the graph will curve downwards, like that. Right? So, if the A is positive, the graph is an increasing, we call it an increasing function. Remember, I introduced the concept of increasing and decreasing function long time back when we were talking about the quadratic function. So when A is positive, the function is increasing. Increasing function. Okay? When the A, please, the B can never be negative, and the B can never be equal to 1. Okay? But the B can be between 0 and 1. It can be greater than 1. It cannot be 0. It cannot be exactly equal to 1. Okay? So this B, it cannot be 0. If it becomes 0, it means the exponential function doesn't exist. If it becomes equal to 1, it means the exponential function won't exist. So the B can never be 0 and it can never be equal to 1. Okay? So the Q represents vertical shift. The value of A determines the curvature, whether is it an increasing function or is it a decreasing function. Okay? So, and the other thing as well, this is very important. If A is less than 0, generally it means the curve will be below the asymptote. If it's positive, then it will be above the asymptote. Okay, so here it will be a decreasing function. Okay, it will be a decreasing function. Okay, please, I want you to know that, know and remember that the Q represents the vertical shift. The A for the exponential function, it determines the curvature, whether is it curving upwards or is it curving downwards. Okay, and the function has got a horizontal asymptote. The curve can be above the asymptote or it can be below the asymptote. Okay? If A is negative, then it will be below the asymptote. If it's positive, it will be above the asymptote. Okay? So that's what you must remember always. Right. Let me carry on. Right. Don't worry if you're behind, I'll send you the PDF. Okay, don't stress. Right, so let's move on to the the properties of an exponential function. Now, the properties that we are going to talk about here, they are referring to the shape. So we start with the shape first. Okay, we talk about the shape, x-intercept, y-intercept, the asymptote. Okay, and then we may also talk about the domain and the range. Now, when it comes to the shape, well, it's very important for you to know that the shape is dependent on mainly the value of a, that is whether the graph is going to be going up, that is it's going to be an increasing function, or it's going to be a decreasing function. So the value of a determines that. But the b has got two cases. Okay, this b, it can be greater than 1. The b, which b am I talking about? The function is y equal to a times b to the power of x plus q. So you can put a times there. Please, b can never be negative. It is a that can be negative. B can never be negative. So, if b is positive and is greater than 1, let's say if a is less than 0, but your q is greater than 0, it means q is positive, means the graph goes up. But the a is negative, the graph will go down like that. Okay? It goes down because of the value of a. The a is negative, therefore it will be a decreasing function. Okay? The moment the a becomes positive, the graph will go up. That is also when q is positive. So whether the graph is increasing or decreasing, it is dependent on the value of a. If q is negative, it means the graph is going to be below the horizontal asymptote. In fact, when it means the graph, if a is negative and q is less than 0, it means our value at the horizontal asymptote will be below the x-axis. Okay, and it's going to be a decreasing function because the a will be negative. Don't worry, I will show you some examples just now. Then when a is positive but q is negative, it will go up, but the graph will be above the horizontal asymptote. So when a is negative, the graph is decreasing. When a is positive, the graph is increasing. Okay? Q does not affect whether the function is increasing or decreasing. Q only determines the vertical shift. Okay? So those are the 4 scenarios when b is greater than 1. Okay? Depending on the value of a and q. Now you can also have another scenario where your b is a fraction. B can be a fraction between 0 and 1. B cannot be 0, B cannot be equal to 1. Okay? Now, when B is a fraction, okay, the function is going to be increasing or decreasing as well, depending on the value of A. So if A is negative and Q is greater than 0, the function is going to be an increasing function. Okay? Now, what happens here is that the curvature will change slightly because of the value of B. The curvature will change because of the value of B. Okay? If it's a fraction, the curvature changes slightly as compared to when it's above 1. Okay? But in terms of whether it's increasing or decreasing, it still depends on the value of A. A is negative, it's a decreasing function. A is positive, it's gonna be in this case here. Okay, I need to reiterate that if the b is a fraction, then the function is gonna be increasing even if a is negative. Okay, please, I'm gonna reiterate that fact because it's a little bit confusing. Usually when b is negative, when b is a fraction between 0 and 1, if a is negative, okay, as long as b is a fraction between 0 and 1, the function will be increasing. It's the opposite of what you have there. Okay, I'll tell you why just now. Let me just tell you why. Right, this is very important. So it's the opposite of what you have there when b is greater than 1. When b is between 0 and 1 and a is negative, we have an increasing function. If a is greater than 0, we have a decreasing function. Okay? So again here, the q is negative, but because a is negative, we are going to have an increasing function. Here, a is positive, we are going to have a decreasing function. Okay? So there are two cases when it comes to the exponential function. One when b is greater than 1, and another one when b is between 0 and 1. Okay? So you need to be familiar with the shape. Whenever you get the function, you must have an idea of how the graph is going to look like. Okay? The exponential function is a curve. Okay? I don't want to hear someone speaking without confidence. The domain is the set of all the x values. The domain, the range is the set of what? All the y values. You don't have to say that with some kind of doubt or something.
What did say again?
Domain is the set of all the x values. Domain is the set of all the x values. It's a very important word in maths under functions. The range is the set of all the y values. If I ask you what's range, what's domain, you don't have to say it with a doubt. Imitate me, I'm saying it with confidence. Range, set of all the y values. Alright, so here, if you want to find your domain, okay, the range, okay, let's start with the range first, based on this. Now, the range is affected by the value of a, because see, if a is an increasing or decreasing function, the way you write the range will change. So, if a is greater than 0, okay, if you substitute an a which is positive here, you find that your y will always be greater than q. But don't stress, because this might confuse you a little bit. Okay? I'm going to do an example with numbers, and then I'll sketch it, and then you can be able to understand it. So what you need to know for the range, the value of a affects the range, because remember, a determines whether the graph is an increasing function or it's a decreasing function. Okay? Obviously, the value of q is also part of the range, because q is a y value along the horizontal asymptote. Okay? And b sometimes might also affect the range, because there are two cases of b. B can be greater than 1, or b can be between 0 and 1. Okay? So the range is affected by the value of a. Okay? Then the intercepts. Okay? The intercepts. Okay, whilst I'm still talking on here, the domain is 2x is an element of real numbers. Okay? The domain, okay, the domain is going to be x is an element of real numbers. The domain is always x is an element of real numbers. It's only the range which changes a lot because of the value of a, the value of b, and the value of q. Okay? So make sure you're aware of that. Then your intercept, okay? You have a y-intercept. To get it, you substitute x equal to 0. When you simplify, your y-intercept is always y equal to a plus q. The y-intercept is always equal to a plus q. That's your y-intercept. The y-intercept is always equal to y equal to q. Don't worry, the a cannot be 0, obviously. Okay? A cannot be 0. Right? So you always have a value for a here. Q can be 0. So sometimes the y-intercept can be the value of A. If Q is not equal to 0, then it means you just add the value of A plus the value of Q. Remember, the A can be negative, the Q can be negative as well. So the general equation of the y-intercept is y equal to A plus Q. The x-intercept, you substitute, it's a little bit more complex because you require knowledge of the exponential equation, which in the last test you wrote, many of you could not answer the question on exponential equations. Your knowledge of exponential equations is required when you are dealing with the exponential graph, especially when you want to find the x-intercept. So in this equation, y equal to a times b to the power of x plus q. If you want to find the y-intercept, you just substitute x equal to 0. If you want to find the x-intercept, you substitute 0 there. And then you get a times b to the power of x plus q. To carry on, you need to make that b to the power of x what? The subject. You isolate the b to the power of x. So when you do that, you take the q to the left, you get minus q equal to a times b to the power of x. Then you divide both sides by a. So you get minus q over a equal to b to the power of x.
So, what is it now?
I'm talking about the x-intercept.
No, but that's where you equation.
No. Okay, maybe I can say yes. Was the concept of literal equations is required when you're dealing with any equation. It's a very important concept. Knowing how to make a variable the subject, it's a very important concept. So your knowledge of literal equations is required. Okay, so what I'm saying here is, because it's an exponential equation, if you want to get the x-intercept, your knowledge of exponential equations is required. So don't stress this minus q over a. It's a specific value which depends on what q is going to be and what a is going to be. Okay? So if you want to solve for x, it means you need to make this equal to b. Remember, when you're solving an exponential equation, if I give you, say, 2 to the power of x is equal to 8, how do you solve for x?
You make x equal to 2 using the exponent.
You convert 8 to what? The base of what? 2. The same concept applies here. You convert this minus q over a to what? To b. So if b is 2, you make this minus q over a equal to 2. If b is 3, whatever you have here, make it equal to 3. If it's not possible, then it means there is no x-intercept. If you can't convert this minus q over a to b, it means there is no x-intercept. So straight away you say, therefore, x is undefined, no x-intercept. So sometimes the x-intercept for the exponential function may not exist, especially if the curve is above the x-axis or if it's below the x-axis. In that case, it has to be above an asymptote which is above the x-axis, or the x-axis itself is the asymptote. You can also have a case where the horizontal asymptote is below the x-axis and the curve is below the asymptote. Then no x-intercept. The y-intercept always exists. The y-intercept always exists because of this. Okay? Please don't stress if you don't understand it now, because I need to show you a question. But obviously, I cannot start from a question with numbers. I start from properties. That's how it has to work. Okay? So don't stress about what I just said here. If it confused you, it's fine for now. Later you will understand it. Don't worry. Then the last part, the asymptote. The exponential function has one asymptote, and it's a horizontal asymptote. The exponential function has one asymptote, and it's a horizontal asymptote. The equation of that asymptote is y equal to q. Remember, the equation of the horizontal asymptote of a hyperbola is also y equal to q. The same y equal to q is the equation of the horizontal asymptote of the exponential graph. But the exponential graph does not have a vertical asymptote like the hyperbola. So if you know how to sketch the hyperbola, you shouldn't have any problems with the exponential function. Okay? So make sure you know that. Right? So let me now move on to